There we go, and I got to make sure I hit it this time too. Thank you for reminding me, though, that you can be from more than one program. So for those of you who are from other programs and you find that you like the quantitative methods, wouldn't it be nice to have a line on your CV that shows how good you are at it? You can sign up to get a master's degree for 30 credits, many of which you probably already have from requirements from your primary degree, as well as counting every class that you've taken at the university. So if that's something that you're interested in, please feel free to reach out to me or any other EMS faculty. It's a nice add-on for your package. Because if you know how to do stuff with data, people will pay you. That is my honest belief. It is a skill set that will help open doors for you beyond the thing that you came here to get good at. So, welcome everybody. All right, let's see here. I put together a PowerPoint so that I wouldn't ramble too much. And for those of you who are here already, feel free to check your email or something because the first 10 slides are going to be the same. What to expect this semester is where we're starting here. And then a little bit about what the class is going to involve. So we're here to expand your knowledge of quantitative methods into what is known colloquially as measurement. However, factor analysis and structural equation models are indeed statistical models. And so this is one of those classes where that measurement and statistics label really doesn't fit. It is both at the same time. It is a model for measurement purposes. But along the way, these models can be used to do a whole lot of other things once you have tackled the measurement component of it in terms of being able to look at relationships between things as best measured as possible. So there's a lot to unpack here. For those of you who don't know me, rest assured that I am not scary. I don't do proofs. I don't do derivations. I don't make you do algebra. If you want to learn how to invert a matrix, you are in the wrong place. There are places on campus where you can go to learn such things, but my approach is decidedly analytical from the perspective of someone who has data and wants to do stuff with it. So that's the approach that I take, and I want to make this as flexible and applicable and modern as humanly possible. The hard part about this class and all of quantitative methods to me is not the math. The computers are going to do the math for us, and they'll do it faster and better than we ever could. The hard part is the language and the notation. This class is very different because the focus is not really on prediction. In every other class you've probably taken up to this point, we've had an outcome and we've had predictors, and we look at how the predictors relate to the outcomes. That's kind of not the point here. That's going to be like the last week of this class. It's a very different type of perspective. And so there's new notation and new vocabulary and new concepts, and to me that is the part that makes it harder than what would otherwise be. But I will help you walk through that. So I believe we can all do this. You wouldn't be here if you weren't prepared and skilled enough to do it. I try to focus on accessibility and mastery. The materials that I will give you, I try to group them into units. And to me, a unit is a combination of a lecture and then potentially one or more examples that go with it. So for instance, the invariance unit has 4 examples. This unit doesn't have any, and I'm hoping to get through all 10. The slides that you'll see tend to describe the what and the why, and then the examples show you how to actually do the things using software. And both of those I think are equally important. I have a note here that yes, I know my slides are really wordy, and I'm not sorry. I'm not. I've planted my stake in the ground, and I'm going to have jam-packed slides because I don't want you to spend your time writing. I want you listening and thinking, and maybe jotting down a note or two, but I want most of what I say to be in front of you already. In one of my other classes, I had students who actually walked on the treadmill during class. They got their steps in, and I'm very proud of that. I feel like that's a good thing if you're able to focus to that extent and get your exercise in. So the software that we are using in this class is going to be either M+ or R. All of you should already have access to M+ inside the University of Iowa's virtual desktop. I made sure of that over the summer. So that is something that at your nearest convenience you should check to make sure that is included in your package. I am not assuming that you know how to use M+. I'm going to teach you how to do that. It's really easy. It's a very easy language. It's very powerful. In R, we will be using the package Lavon to do most of the same things, but not everything. And that's why I focus on M+, is because to me, it is the best package, and it has the most capability, and it's constantly being updated. Lavon can do a lot of things, but it can't do everything. But you can use either package to do all of the course activities, and I will show examples using both. All of the materials are going to be at the course website. The only thing that I use Icon for in terms of providing materials is for the readings. And there is a zip folder of all of the readings for this class, including the parts of the textbook that I'm using. So all of that is ready to go. You can download it at your nearest convenience. So I don't do tests. That's sort of ironic, since this is kind of a class about tests. I don't do tests. The reason that I don't do tests is that I don't want to include construct-irrelevant variants, like anxiety, or things like that that can creep into your performance. You know, my husband has a sister who is an emergency room nurse. She needs to know something right now, or this patient is going to bleed out, right? But I don't have to be like, Vladimir, tell me what a lambda means, or else. Right? If you don't know that right now, this person's going to bleed out. Like, that doesn't happen in this class. So I don't do tests. So that's one thing that makes this different. The other thing is that, in contrast to the title factor analysis, I'm not going to talk about exploratory factor analysis because it's a giant waste of time. It's one of those things that used to be much more important, and to me, it's just not useful. Now, I am going to be out of town for a conference in October, and I have some materials, lectures that I gave last time, and then other lectures and materials that I'll have so that you can learn about why I think it's useless, but I'm not going to waste a lot of time on it. Same thing with principal components, slightly more useful, but not also something that I'm going to focus on. I'm also not going to focus only on what would be considered typical structural equation modeling, which is usually only for continuous outcomes. Most scale type items that people would be analyzing to build a test or to build a scale to measure something are not continuous. They're binary or ordinal or nominal, or at most you might have a slider bar where you can say like how far over you are, but these have endpoints, and so it's not continuous. So to me, SEM focusing only on continuous responses is just not good enough for practice. And so my approach is to teach it from a very holistic point of view. How do I build a measurement model to examine whether I'm measuring one thing or two things, and what's related to what, regardless of what kind of responses I have? So it really is a class on generalized modeling as much as it is structural equation modeling. Question in the back? I had a unit on that a long time ago, but I never get time for it. So he asked, the question was, are we going to cover DCMs, which I'm assuming means diagnostic classification models? Those are measurement models where the latent variable is categorical instead of continuous. I can give you resources on it, but no, it's not planned. You might be able to get a class on that if you ask Jonathan nicely. He's tired of teaching it, but he needs to bring it back out again. So I will use two different types of activities. Formative assessments is one, and homework is another. So for those of you who haven't had me before, formative assessments are available under quizzes in Icon, but they're not quizzes. They are opportunities for structured review. So I'm going to build in 5 this semester, big picture questions, vocabulary drills, that kind of thing that I hope that you should be able to answer off the top of your head. And if you can't, then that should be an indication of what you need to review. So it works both ways. I hope to give you prompts so that you can evaluate your own following of the material, but in turn, when I read your responses, it helps me know whether or not folks are following. So if people give like a common wrong answer, then I know that's something that I definitely need to spend more time on. So each of these, you get 2 points for doing them at all. I'm not going to grade them for accuracy, they're effort only, and we'll talk about them the next day after class each time one is due. The other thing that you'll spend your time on is homework. And in this class, it's going to be of 2 different kinds, canned and real. So I have 3 homeworks that are going to be using a custom online system. It's the same one that you're used to if you've had me before, where you get immediate feedback, and I'll describe that in just a second, but also 3 using your own data. So you will get the chance to get practice implementing techniques on data that you care about as part of the requirements for this class. Everything is take-home, everything is open note, and everything is untimed. No anxiety needed. I don't care how long it takes you to get something as long as you get there eventually. That being said, I know that things with hard deadlines get done and things with soft deadlines get rescheduled. I don't want to be in the rescheduled category. So I have a small penalty. This semester I'm going with 2 points off for a late homework, 1 point off for a late formative assessment. It's not per day, it's just period. So if you get stuck in a jam and you can't get to something on time, it's a 2-point hit, but nothing you can't come back from. Homework 0 is the first thing that I'll have you do just to test out the system and make sure everyone can get to it. And you get 2 points extra credit for doing that. So you get 1 free late homework. If you look at the schedule and you see a week where it's like, oh, I'm going to be out of town that week, or I have X, Y, and Z other things that week, send me an email and ask for an extension, and I'll be happy to give it to you. So if you're planful about being late, I can work with that. If I am late, so if I have a sense of how long things should take, but if I'm wrong, or I should say when I'm wrong, I will push the due dates back accordingly. I want you to have at least a week after we finish something. And the way that the homeworks are situated is that you'll have a canned data homework where you practice and you get instant feedback, and then you'll do the same thing on your own data. And then we'll introduce a new set of models and you'll get practice with that, and then you'll do it on your own data. So that way, each thing is sort of, it builds on itself in terms of the repetition. So formative assessments, as I said, big picture review we'll go over. All of the homework assignments, I will show you how to do everything that I'm going to ask you to do in class. There will be no Googling required. How do I make R packages do this? No, look at my notes. I'm not going to ask you to do anything I haven't shown you a version of. Online homework has 2 parts. One is computation sections. So I might ask you something like, what is the factor loading for the first item? And you'll look at your data, run the code that you need to run the model, input the number. If it's right, it turns green. If it's wrong, it turns red, and you can try as many times as it takes to get it green. Instead of having a results section in this class, however, the next part is just going to be multiple choice questions. So there's not like a story where there's a write-up, because your data assignments, you get practice with that instead. So those are multiple choice questions that are sort of broader, and you get eventual feedback after the due date has passed. So you won't see if it's right away, but eventually you'll see what the right answer should have been if you get it wrong. And the first homework 0, the practice homework, I'll put up a video walking you through it, and you'll get a chance to see what all of this looks like in practice. Your written assignments, so there will be 3 of them, you do get a chance to revise them. So just like anything in academia, manuscripts, grants, conference proposals, everything comes back with feedback that you have to attend to. So learning how to revise and be responsive to feedback is something you got to learn, and hopefully it will make your work better. So each homework needs to be at least 3/4 complete for me to take it. So you have to make an honest effort to finish it. But if you get stuck, that's okay. So you'll send me your work, I'll provide you with feedback, I'll, in comments in Word, tell you what to change or what needs to be included, what you missed, etc. And then you'll get a chance to fix it and get all your points back. So 1 revision for each one, and the last one will be due at the end of finals week. No tests, just the usual stuff. All right, any questions so far? Course activities. No, am I talking too fast? No, really? I thought for sure you were going to be like, yeah, take it down a notch, Lise. I'm excited to be back. Can you tell? Yeah. All right, my job, answering your questions. Please don't be shy about asking questions. If you ask a question in class, one of 2 things is going to happen. Either someone else is going to be really relieved that you asked the question so that they didn't have to, or someone will have the answer in their head, hear me say it, and then feel really good about themselves that they knew what the answer was. Either way, it's a win-win. I would prefer questions happen during class, that way everybody can hear the answer and have discussion. But if you're shy, You can email me, you can talk to me in office hours, and even if you're sitting here in the room, you can log into Zoom and use the chat function if you want to ask a question privately. That's fine with me, and I've trained myself to watch for that. So I'm looking at the screen here with the Zoomers in the chat window as we speak. In terms of office hours, I'm doing them only on Zoom, and unlike in the past, I moved them to Monday and Wednesday afternoons because so many of you are here all afternoon with me. I didn't think you wanted another hour. So 3:30 to 4:30 on Mondays and Wednesdays is when Zoom office hours are going to be. The way that I run them is with everybody in a group. So you can log in, ask your question, and log out. Or you can just log in and work in the background until you have a question, ask me your question, and then keep working in the background. It's up to you. So it's just like a free-for-all. If you want to have a private conversation with me, then please ask me for an individual appointment, and I will be happy to set that up with you as well. Oh, and I will stay the whole time. So like if you have a question and it's 4:28, go ahead and log in and ask me. I will be there. I don't leave early, especially on Zoom. I can always find things to do on my computer. So ways to spend your time in this class. Asking questions when things are unclear is number one. Frequently review. So going back over the lectures, the videos, the code, the symbols, the notation, all of that so that it starts to become more automatic will help you. Not waiting until the last minute for homework is another big one. And if you're trying to make something go and it doesn't work, so you're not getting the right answer or you're getting an error message in your program and it's happening for more than 15 minutes of tries, just stop. Stop right there. Send me a screenshot of what you're trying to do. What's your code? What's the error? Or I think this is the answer and the homework system won't take it. Send me a screenshot of those things and I will help you troubleshoot. I say screenshot because then I can look at it on my phone and type back very quickly. If you send me your whole code, then I have to go to my computer, open the computer, download the file, open the file, look at the file, and then type back, and it's longer. So screenshots are very helpful. The readings. So there are, I'm going to use a technical term here, a shit ton of readings, a metric shit ton of readings this semester. You don't have to read them all if you don't want to. But my thought was that I want you to have extra examples, extra discussion, extra exposure to current best practices, because SEM is a huge, huge world of research. What the readings that I've given you, I don't even know how many there are. There's a lot. It's just the tip of the iceberg, and I have like hundreds and hundreds of other articles that I was selecting through to try and decide. So I know it's a lot of readings. The textbooks that I'm using, the Brown CFA textbook, Susan Embertson's textbook, and then there's another one I added this year about IRT. Those are sort of like the core, and the articles are meant to supplement that. So if you're looking at the list and going, I don't have time to read 10 articles this week, Lisa, it's okay. It's fine. There's more for your future reference. And last but not least, I'm giving you practice on data that you care about as part of the course. But if you have other data that you're interested in analyzing, I am happy to talk to you about that during office hours or even during class. I want you to use this as a springboard for doing actual analyses that end up in publications. And there have been a large number, actually, of students who have subsequently published projects that started out in this SEM class. In particular, things about invariance. So the term invariance means whether or not a scale set of items works equivalently across different types of people. That has not often been looked at, especially if you're applying something to a new population. That's one type of publication. If you're looking into a scale that everyone in your research area uses, but you go back and see that no one's actually ever done factor analysis on it, which you would be surprised how often that happens, that's a publication. So there are journals that are targeted for measurement type papers. So that would be the end goal of these sorts of projects, is to work that way. So learning with the data you care about will help you a lot more. Question? Yes?
You have to pick one or two references as the primary ones. I know, like, you've given a lot, so which one would you say would be the primary ones?
So the Brown CFA textbook, I'd say, is the primary. It's a book called Confirmatory Factor Analysis, and so it does sort of the bread and butter of what the course is about. When we get to the IRT section of the course, then we get into the Embertson and Rees textbook, as well as the new one I added, This is we called them Greeny Weenie books in grad school, but it's like the Sage Little Green Book series. This is a little Greeny Weenie book. So it's about polytomous IRT models. So I would say like those are the ones to start with. And then as you have time to incorporate the other ones, I tried to place them about where I thought they would be relevant for what we're talking about, but it's not a strong one-to-one correspondence. It's just my best guess. And I have the full list of all the references with all the DOIs and stuff down here. So. All right. Other questions while we're at it? All right. Then, in terms of attendance, I'm not going to take attendance. If you need to miss a class for whatever reason, I'm okay with that. I assume that we're all grown-ups, you're all in charge of your time, and I trust you to make the best decisions with the limited amount of time and energy you have. That being said, if you ghost me, if you don't show up for weeks at a time and you don't turn in your stuff, then I will be concerned. But if you need to miss class for whatever reason, I'm okay with that. If you're going to be here in person, I strongly encourage masks so that everybody can feel safe, myself included. If you are potentially exposed to COVID or monkeypox or monkey COVID or whatever the hell new thing happens next week, please don't come make us sick. You won't miss anything because I record the classes. You can Zoom from home if you're feeling up to it, or just not come at all and watch the recordings later. Everything is going to be on YouTube, the audio and the screen share, so you won't miss out on anything. And I will post the videos right after class each day so that you'll have a recording. If I forget to hit record, and now I'm going to check just to make sure because I have done that, I will re-record the video. So you never have to worry that, like, if I don't show up, I'm not going to get it back. Don't worry about that. Questions at any point during class are welcome. You can use the chat window or your voices as you prefer. And if there's anything that needs to be changed, I will send out an email by 9 a.m. on class days. So for instance, if we get hit with a freak snowstorm and Iowa City schools are closed, odds are good we're moving to Zoom because I have to go be mommy as opposed to just Dr. Mommy, which is normally what I am. Likewise, if I get exposed to COVID, I'm not going to make you guys sick. I am going to Zoom it instead. So I will not hesitate to eject to a Zoom-only class if that's what's needed. And in fact, there's going to be 2 days this semester, September 8th, I want to say, and sometime in October, where we are losing this classroom because of comprehensive exams. And so we're going to be on Zoom those days anyway. They're on the syllabus. I already found out about those, but just check your email if it looks like if there's bad weather or otherwise. That way you can make sure that you don't drive to campus if you don't have to. All right, about software. So M+ is up to version 8.8, and that is the version you have on the virtual desktop. I managed to get that updated this summer. It is super expensive to buy. I do not expect anyone to purchase the software. If you wanted to purchase it, I believe a student license is somewhere around $400. Yes. For a student license, it's because a non-student academic license is about $1,000. Yes. It's super expensive. The reason is because it is constantly updated with the newest and coolest stuff, and because they have very, very extensive documentation, examples, short courses, web notes, etc., and a message board where the people who make it will literally write back to you and answer your questions. So they've put a lot of effort into this. We have a license that you can use as part of this class. It does everything. That's why we're using it. It is also relatively easy to follow. So M+ syntax is completely straightforward. It's very easy to replicate. For those of you who are heavy-duty R users, there's a package called M+ automation that you may want to grab because it helps make the file management side of it. Basically, you can call M+ from inside R, bring the output back in, and it's parsed into objects that you can do stuff with. So it makes the process a lot more seamless if you're going to be using R to do other things. Otherwise, you can just use M+ standalone. M+ automation is the name of the package, and I believe it's title case, capital M, capital A. Yep. Yes?
Just a question, like...
One second. Go ahead, Ryan.
Sorry.
No, go ahead.
It's me. So just a question, so if you purchased using your student license, will it expire after you graduate, like you're not a student anymore?
Ah, great question.
Or it's
No.
for like a long time?
So strategically, if you have like research funds or some sort of money that you need to spend on something, and you buy a student license, you could have that license for the rest of your life if you kept renewing it. So if you're in that situation where you have $400 and you want to buy it, that would actually be a good strategy. M Plus does not expire. You can use M Plus forever, but you can't update to the newest versions unless you have a renewal fee of $175 a year. I know. The mutanes sleep on a bed of money every night, I'm pretty sure. Because they also do workshops where they charge, $200 a person per day in a room of 200 people to do the software. So yes, it's the whole enterprise. Farhan, did you have a question too?
Yeah, now I have two questions.
No, two questions. Okay.
So, first one is there any advantage to using M plus through R, other than the convenience of staying on R?
Yes. So R does not have a maximum likelihood version of SEM that has as many link functions as M plus does. So for instance, the Lavon package is the one that I will be using in R. That package allows ordinal or binary indicators only under limited information maximum likelihood, not under full information. It doesn't have things for like counts, for instance.
Yeah, well, I think I miscommunicated. What I meant was, is there any advantage to using M plus through R as opposed to using M plus through its own software?
The only situation in which it would be advantageous, I think, to run it through R, actually there's two. One is if you're doing simulations. So like if you're making up data and you want to go run a model and then save the results and stack it all together to analyze that, then doing the data management in R is going to be much easier. The other is to get out of like file hell, basically, because what makes M Plus different than other packages is that you can only have one model per script. So you can't have like all your models in one file. It's a separate input file and a separate output file. So you can end up with like 7,000 files to keep track of, one for each model that you tried, and that gets ugly quickly. So the M Plus automation package, I think you can stack your code up in R into one file, and then it will go and create the multiple files, but then you have the R file that organizes everything.
Okay, so you covered that, right?
I have not used M Plus automation. This is one thing that I have not tried yet, but Jonathan likes it, and I've heard very good things about it. I have learned how to use Lavon since the last time I taught this class. So I can help people in Lavon and do that now, whereas I didn't before.
And second question, can I ask?
Sure.
So, do you think there are going to be any massive groundbreaking changes in M Plus anytime soon that would require renewal and getting the latest version?
For what is being covered in this class, no. For what is being covered, say, like in the upper end of the longitudinal, what I want to do in the spring, yes. So, and in a lot of other areas. We have a comment about the M Plus website. It says you can use the student version you purchased while you are still a student for up to 4 years. That is their official policy. But I will tell you that the software does not know who installed it or when that happened. So, all right. Did I get all the questions? Just think about it this way. Every package that you learn how to use is one more line on that CV. All of you should have something called like a technical skills or something along those lines where you list all the different statistical models you can do and all the different packages you can do them in. So it's one more thing. I use M Plus for basically anything that's latent. So it's my go-to for everything that SAS can't do. How's that? Question?
Have you done anything with the actual like SEM package in R? It's really new. It just came out this year.
I have seen a few things, but I have not personally done it. My understanding is that like the Lavon package has several different routines within it Like there's like a CFA routine and an SEM routine, and like some of those have built-in defaults that save you time and code. But I don't like teaching that way. I deliberately, in M+, in R, in SAS, in every program that I write, I deliberately write out everything so that it's completely transparent what's happening and you don't have to memorize which defaults apply to which situation. For instance, in M+, if you're fitting a longitudinal model in their multi-level syntax, the intercepts and slopes are not correlated by default. If you fit the exact same model in their SEM syntax, they are. I don't want to have to know that. So I will either put the correlation in there or not, right? Like I'll write everything out. So to the extent that they're trying to save you typing, that would be advantageous, but not to the extent that you're trying to be transparent, I think. And the other thing is that defaults change between versions. So like your code may not be backwards compatible necessarily, which is always a problem. All right, other things on the topic of M+, or R for that matter. I have other possibilities. Yes, okay, I'll leave this on. Go. Oh, yes, Stata. Yes.
Sorry,
Yeah.
had to ask.
Yeah. So Stata has an SEM and a GSEM. They handle missing data differently. Lavon and M+ allow you the choice as to how you treat your predictor variables, whereas Stata does not. So it may be the case that you could use Stata for some of the canned data and get to the same place, but I can't guarantee it. If you wanted to use Stata to analyze your own data, I'm totally fine with that. But for comparability across programs, I can't guarantee that it will work. But it's a nice package. That's ironic, in Stata syntax, that's the one time you can use capital letters is to name a latent variable. Seriously. The whole thing is lowercase except for that. If it's imaginary, it gets a capital letter. SAS also has a package Calis, and SPSS has a package Amos, and to the best of my knowledge, they don't do anything other than continuous responses, and so we won't be able to use them for like the second half of the course, but those are some other choices. I actually learned SEM on EQS software back in the day, which I think is still a thing, but just barely. And I once went to a workshop on Lizral and went, and that was it. That's another technical term. That's my expression for, you want me to specify these as matrices? Seriously? No. And that was the end of that. But both of these packages, the language is pretty straightforward. Lavon in R and M+, the language is relatively easy to master, so it's not so bad. All right, other software questions. How are we doing? 2:43. Okay. So the organization of the semester then. Section 1 is sort of concepts and old school stuff. Like I said, I decided to move the dimensionality discussion regarding exploratory factor analysis and principal components to the middle point of the course, where you will watch it while I am not here and then probably understand why I hate it so much. We'll talk about, today sort of as an overview, today and Thursday is an overview of what we're going to cover a little more specifically. We'll talk about reliability next and why alpha is terrible. I know, right? She said, what? Yeah, Cronbach's alpha is useless. You heard it here first. I'll tell you why next week. I have a lot of opinions. That's okay, though, because I'll back them up. I'll tell you why I think that, and you can agree or disagree. You'll do omega instead, by the way. Section 2 is the bread and butter of the course, sort of how to model latent traits regardless of how they're measured. And so then we get into continuous responses, categorical responses, and other kinds of responses, as well as the examination of measurement equivalence across groups and time. Then the last part is where we get into what would be called sort of SEM proper, which is all about relationships among the latent variables that you've created with your measurement models, and how to deal with some of the trickier issues. Like, what if some of my items are positively worded and some of them are negatively worded? You're going to end up with two factors. I'm just going to tell you that now. That is what's going to happen. So if you don't want to have two factors, what are some other choices and what are the implications that they have for how you think about your model? That's what we'll talk about. And then getting into SEM at the very end in terms of the relationships among the factors, because that part, honestly, is super easy. It's building the factors in the first place. That's hard, and that's why we're spending most of the time on that. All right. Homework. You don't need to have your own data yet, but I want to plant the seed for what I'm looking for. So homeworks 1, 3, and 5 are going to be completed using your own data. 1 is going to be, where did these items come from? I want you to read 1 or 2 articles that were originally written to describe this new scale, to measure the such and such trait, and answer some questions about it. So it's a relatively, there's no data analysis, just understanding like where did this stuff come from and what's been done. And then 3 and 5 will be actually implementing the measurement models. So what I would like for you to find is at least responses to at least 6 items that measure 1 trait, or if you have fewer than that, 8 items that measure 2. And the reason for that is that if you have fewer, there's not as many things that can go wrong and it's not as fun. Any response format will do. The way that I have envisioned this is ordinal responses, like a Likert scale, like strongly agree, neutral, like that kind of thing. That's what I had envisioned. But if you have some other kind of data, like response time, or eye fixations, or a slider bar of you know, how much do you agree with the statement, any of those will work too. If you're not sure if it will work, let me know. I don't have a sample size requirement in terms of the number of responses, but at least 100 would be nice. If you only have like 10 responses, there's not a lot I can help you do with that. More is always better. In terms of the source, please talk to your mentors, collaborators, anybody that has item level data where maybe if they've made up a scale and they haven't validated it yet, or if they've administered a scale to a population for whom it wasn't intended. Anything like that would be a great opportunity. If you're somebody who doesn't have data, here are at least 2 places on the internet where you can find tons and tons of data. The International Personality Item Pool has a whole bunch of different data sets measuring all kinds of psychology type stuff. ICPSR has data sets of various kinds, all sorts of fields. I have tons of data in my own person, so if you can't find something, let me know. But the idea is that I want you to have practice on something that you care about and hopefully turn it into some kind of presentation or publication. So any questions on that right now? So that, let me get to the syllabus here for a second. The first homework is not due until week 5. And you don't have to have the data by then, you just have to know what scale or what instrument you're using so that you can do a lit review on it. So you have a ways to figure this out. All right, so switching gears then, what are we going to talk about? That's the next part, but I'm going to answer your question first.
I just had like 6 surveys come to my mind, but none of them are super like established scales.
Good, that's what I'm looking for. You're going to establish it or watch it fall apart, one of the 2.
Okay.
No, seriously. You would be surprised like how many scales where it's like, well, this person did the reliability and the validity, and when you go back to that article, it's EFA and alpha. They haven't actually done anything. And so that becomes a validation study type, you know, like does the factor structure actually hold up the way that people are treating it this way in practice?
But some of the surveys I'm thinking about like haven't even, like it's like, for example, SARU, the Student Experience at the Research University. Some people have created scales out of those questions, but I don't think there's like established scales of like, this is looking at a particular construct. Is
okay.
That's okay?
Do you have like, can you think of items that should go together to measure a construct, like logically, theoretically?
Yeah.
Great. Okay. Yep. You don't have to be right, but you just have to have a clue. Like if you have a place to start, then the results of the analysis will actually help guide you into what it should be if you're wrong. You just got to have a starting point. Okay. Other questions? Data? Software? Are we excited? Are we still awake? Maybe I should start there. Aim low. Yeah. All right. I'm excited. So one thing that's funny to me about the material in this class is the word theory gets attached to all kinds of stuff, like classical test theory and item response theory and test theory. We don't call it like regression theory or multi-level modeling theory. It's a weird name, but the reason that there are the same ideas described with different words and notation is because these models came from two different places. And so I just want to give a little bit of background as to like where this stuff came from and why it is the way that it is in this sort of like bifurcated manner. So psychometric theory is another synonym for this, but the idea of a theory as to how you're going to measure something that's unmeasurable with measured things. Like, so it could be ability, it could be personality, it could be tendencies, it could be attitudes, it could be lots of things. So the models that we're going to talk about are ways of operationalizing and providing answers to questions like, do these items actually measure one thing or is it two things? Does it matter if I use reverse-coded items? Are they different? They are. I'll tell you that right now. Have you ever asked somebody, like, if you buy them a present and you say, do you like it? And they answer with, I don't hate it. Is that the same thing? Not really, right? So there's a lot of well-meaning item development that goes into place to try and measure something, but whether it actually worked out the way you thought it would is the question. So these are models that are designed to answer questions about reliability, dimensionality, and eventually validity in terms of whether or not you're actually measuring what you think you do. So these are indeed statistical models, even though it's focused on measurement. There are sort of three branches that are interrelated that we'll talk about this semester. One of these you probably know already, which is classical test theory. Now, this is a term that when I was in graduate school, like I never had. Like that wasn't a thing. And so I took a class on item response theory from Susan Embertson in grad school. She's like one of the queens of that world. And the first chapter of her book is contrasting classical test theory with IRT. I'm like, well, that's great, but I don't know what this thing is. Yeah, you do. Classical test theory is the logic under which it's cool to add up items and do something with the score. So everything that you learned in sort of an introductory measurement class about how do we define and operationalize reliability, how do we think about validity, what makes an item a good item, and how would you know that from data? All of those sorts of things are housed in this world of classical test theory. The way that I view this in the context of this class is that it is indeed a model. If you add items together and make a score, and you want to believe something about somebody based on their score, that is in fact a model. It is a very strict parallel items model of a latent trait model. A sum has a meaning. So that's the way that I look at it, is that whether or not it's sufficient to just add your items up and call it good is an empirical question. And the answer is usually going to be no. Only in very certain circumstances would that actually work out as intended. And by the way, I'm abbreviating the word probably with pry. That's one of the words you will hear me say this semester. It's pry not going to work. So latent traits is what we are trying to measure. What is a latent trait? Lots and lots of synonyms here. All of these words I'm about to say mean the same thing. Latent trait, latent variable, latent construct, latent factor, truth score, test score, factor score, theta, random intercept, by the way, from the other class. All of those words mean the same thing. It's the idea that we're trying to measure something that doesn't really exist, but we believe it does. But the only way that we can see that it exists is its effect on things we can't see. So a lot of the readings will use like the word test, and they're referring to a collection of items. The word scale means the same thing as test. It's just whether you're trying to measure an ability or like a tendency is the difference, but those are synonyms as well. Likewise, you will also see the term item be replaced with the term indicator, because it's an indicator of a latent trait, the response that you give to an item. So latent variables are created as commonality across the indicators thought to measure the same thing. What we are eventually going to do is take basically covariance, put a circle around it, and give it a name. That's what latent variables are. So the extent to which the pattern of relationships among item or indicator responses is consistent with the idea that they measure one thing or two things or three things. That's what we're going to look at with data. This class is focused almost entirely on what is known as reflective indicators, as opposed to formative. So a reflective indicator is the idea that the trait exists, and my standing on this trait causes me to answer the questions in this way. Like if I'm someone with very conservative values, I might think that I'm supposed to be at home barefoot and pregnant instead of teaching in front of you. Or if I'm somebody with very liberal values, I might think that it's just fine. I'm not even barefoot today. I'm actually have my shoes on still. Normally I'm barefoot and teaching. Here we go. There, split the difference. Now I'm middle of the road. But it's the idea that I have this trait or this ability or this whatever that's causing me to answer the questions in the way that I am. That's what the models we're going to talk about are designed for. In contrast, a formative indicator would be something like, a classic example of this is socioeconomic status. Socioeconomic status is usually a hodgepodge of like, where do you live, how much money do you make, what's your education level, how educated are your parents, all these sorts of things that like sort of come together to give you the socioeconomic status. But it's not like it was there in the first place. Another one is, let's say, lack of free time. There are many reasons why someone can be busy. They could be going to graduate school. They could be a parent. They could be taking care of their parents. They could be training for a marathon. They could do volunteer work. They could be active in their church. They could have a million friends and go party every night. But there's no one reason that would cause someone to do all of those things. But the sum total is different than each of those. That's formative. So we're starting from the perspective that there is a trait to be measured and it causes the answers to the question. If that's the case, then the answers should be correlated because of the trait, and after you control for the trait, they should be uncorrelated. The trait is the correlation among the items. A formative model goes the other way. This is also consistent, by the way, with the difference between exploratory factor analysis and principal components. If you've seen those things before in other classes, exploratory factor analysis is a reflective model, principal components is a formative model. It has to do with which way the arrows go, in or out. Reflective is the trait comes first, the arrows go from the trait into the item responses. So the differences between the models. What do we call the trait? Well, when we get to classical test theory stuff next week, it's going to be true score. When we get into confirmatory factor analysis, it's going to be factor score. And because I never use notation that I can't draw on the board reliably, factor score is going to be an F, not squiggle 1, which is the Greek letter that it uses in your textbook. There's two of them. I don't know what they are, but I call them squiggle 1 and squiggle 2 because squiggle 2 has like 2 extra curly cues at the top and squiggle 1 has 1. But I can't draw that reliably, so it's F. Then we get into the categorical items portion of the course, which is item factor analysis and item response theory. And then it's either going to be factor score still or theta, depending on who you're reading. But all of those are the same. It's the same idea of this continuous latent trait that is responsible for, that causes my answers to the questions. The difference between classical test theory and the others is what we're actually going to analyze. In classical test theory, the unit of analysis is the test. We end up with a score that's supposed to be our best representation of the trait by adding the item responses together. So the sum is the latent trait from that perspective. That means that who answered the questions and what questions they answered are inherently tied together. You can't compare sums unless they're the same people or the same items. But what if you want to change the items? Well, then you can't compare scores. You need an item level model to be able to do that. So everything else that we're going to talk about is an item level model. We are directly predicting the score for each item response with one or more latent traits. The question is, what type of model do you need to do that? It depends on what kind of response it is. So the fact that we have item characteristics and person characteristics as part of the same model means that there's separability. That means that we can compare latent traits even if they're on different people, even if they're on different items, so long as there is overlap. Overlap is the key. It's called linking in an IRT context. But you have to have common items and or common persons to be able to do that, but they don't have to be exactly the same. Where this gets confusing is that each of these different names is because of a different type of response. That's it. So in the same way that we talk about linear regression and we talk about, say, logistic regression, the analogs in this class are CFA and IRT. So if you've had generalized linear models with me, this will be easier. If you haven't, that's why I had suggested over email that to review those units out of that class, because we're going to do logits and probits in this class as well. So if we're talking about measuring a latent trait with responses that are plausibly normally distributed and continuous, that is confirmatory factor analysis. That's what it is for. If we are unwilling to believe that they are plausibly normal and continuous, such as the case for ordinal data, then that is either item response theory or item factor analysis, which are algebraically equivalent. You can rearrange one to get to the other, but they are talked about with different terms and estimated typically in different ways. Every other kind of response variable you can fit a latent trait to if you know how to do it in software such as M+. So for instance, one of the variables that I had a student project who was looking at counts. So she was from the survey research program at Nebraska, and she was looking at like how good an interviewer was. And it was like the number of times they did this, and the number of times they did that, and the number of times they did that. That's a count variable. Well, that's none of the above, but you can stick a latent trait on it. So if there is a way to map prediction using a generalized model, we can do it with latent variables too. In terms of other terminology, the term SEM, by the way, don't ever say SEM model, because the M is model. That's like an ATM machine. Doesn't work. SEM is a term that refers to a model that has latent variables in it, and it has relationships among those latent variables. That is what it means. If you have a model with only observed variables, and there's relationships of various kinds among the observed variables, that's path analysis, or path models. So path analysis is regression, with more than one outcome typically and more than one predictor. Structural equation modeling is the same idea, but using latent variables to convey the relationships. Other terms that get thrown about in an SEM context, mediation is regression with a better marketing campaign. We'll end up with a few examples of that at the end of the course. And moderation is interaction terms, and you can do that in SEM just fine too. It's trickier to estimate, though, if you're interested in interaction terms that involve latent variables. That's tricky, but doable in M+. All right. So a brief history of test theory then. Some of the advances that we'll talk about came out of an educational context, where the goal is to measure ability and to provide respondents with scores that they can interpret in terms of their teachers, stakeholders, etc. And some of them came out of a tradition of psychology where it wasn't about testing, it was about, is there 5 dimensions of personality, or is there only 3? And people got into fights about this back in the day. And so the factor analysis tradition was sort of built out of this, whereas the IRT tradition was built out of the first one. So that's why there's a lot of, the same idea has 3 different words for it. It's because it's where did it come from and what were the terms that they first adopted. One of the points that I want to emphasize with the next couple slides here that I'll go through pretty quickly is that all of the theoretical, like mathematical work that underlies this happened before computers. So people were like making this shit up in the 40s and 50s, and they didn't have a way to implement it. So a lot of what people were taught sort of in introductory measurement courses, like how do we do things like reliability, it's because they don't require maximum likelihood. Once you have software, you can do all the cool stuff. So things like alpha, you don't need a computer to calculate alpha. You can actually do it by hand. Alpha has 2 things in it, the number of items and the average correlation among the items. That's it. That's all that goes into alpha. So you can have a high alpha if you have a lot of items, or if your items are highly related to each other. That's it. Same thing with principal components and EFA. These are matrix operations that could happen by hand in the 40s and 50s. So there's a lot of like old stuff that got taught because that was the only way they could do it at the time, but we now have better tools. Starting from 1904, 2 different papers sort of track the lineage of what we'll talk about classical test theory and CFA. So here's classical test theory in a nutshell, our first unit. The idea that any sum across items, or mean, take your pick, is going to be a function of an individual's standing true score and some kind of error. And a lot of the emphasis of this goes into how much of it is error and how much of it is trueness, true score. And that is the basis of how one would define reliability, is what proportion of the total variability is due to true score as opposed to error. And then we can use that to make confidence intervals around scores and compute indices and whatnot. But the key idea is that this Y total that we're working with doesn't know how it got computed. It is already an aggregate of individual item responses. So we are assuming, if you add stuff up without testing, that's measuring one thing, that all the items are measuring that one thing equally well, and that there's no other reason why the items should have been correlated. All of those are testable assumptions with measurement models. So under this idea that all of the items are the same, how do you get more reliability? You get more items. What kind of items? More. More of them. What kind? More. That's it. Now that doesn't work, right? Because not all items are created equal, and that's actually a useful thing. So error is a bad thing. And then came along the folks that were like, are you sure error is a bad thing, or is it variance? Now I say this with a, it sounds like a joke, but it's not. I had a major epiphany my first year of graduate school that variance and error are the same thing. I had taken ANOVA classes, and we had talked about between subjects error and within subjects error, and error was bad because that meant you screwed up your experiment. And then I got into regression classes, and it was like variance and individual differences, and variance is a good thing. But error is variance, depending on how you look at it. So why would you have measurement error? How much of it is tied to that particular respondent, that particular situation, that particular occasion? And can we parse that out into making sort of more information about a setting? Well, if you have different dimensions of sampling, you can. So that led into what is also offered here at our university, a class on generalizability theory, which is the idea of quantifying reasons for error as different types of variance. And then you can quantify reliability in different ways depending on which of those types of variance are relevant and which are not. That is the same thing as what I would call a cross-random effects model, by the way. And I'm happy to give you references on that if you're interested. So then we got into, well, how do we measure reliability? And if you're only working with the test score, you don't have a lot of options. So you can do alternate forms and see how correlated they are. You can give your test again and hope that it stays correlated after you give it the second time. You can do alpha, which is basically like split half. And by the way, alpha is called Cronbach's alpha by most people, but actually he was not the first person to make it. There was someone who came before him named Gutman who beat him to it. But for whatever reason, that person doesn't get the credit. So if you read any of the readings by McDonald on our syllabus, he'll talk about Gutman-Cronbach alpha because apparently he was friends with them and didn't want that stuff to get swept under the rug. And then we get classical test theory class courses and books and things that continue up until even today. The other side of it then, confirmatory factor analysis is the first instance we'll see of an item level model. Confirmatory factor analysis is linear regression, where X is the latent variable. The end. If you start from that spot, everything else makes sense. But we got all new words and all new symbols because that would be too fun if it were just understandable. So we are modeling, predicting multiple item responses from a latent trait that we don't have. So what we do have, though, are the means, variances, and covariance among the items, and that's how we work with the model. So it's very different than what we're used to thinking about. The big difference between exploratory and confirmatory is in the names. In CFA, you tell it what is the structure. In EFA, every item is thought to measure every trait, and that can't possibly be true. So we start with the structure, we see how well it fits the data, And more importantly, we can use how well it doesn't fit as diagnostic information. Where did you get it wrong? What does it need to be instead? So revision of the model and adoption potentially in a new sample. That's the idea. So most of the time when people do CFA, they actually probably shouldn't be doing it because most items that I've seen are ordinal and not continuous. So there's a long history as to whether something is normal or continuous enough to pretend. And you'll see heuristics like, well, if you have at least 5 categories of a response, that's normal and continuous enough. Only if it's symmetric. So that's one of the things we'll talk about is exactly what does the model predict and when would you know that you need a different one. All right, so this is what the model looks like. Here's the regression version. Here's the measurement version. Different symbols, different subscripts, but the same idea. So we'll go through all of this in great detail. I just wanted to put it out there as a preview. So each item, I is for item, S is for subject in this class. Each item has its own intercept. What would the predicted item response be for somebody with a factor score of 0? Each item has its own slope. How related is this item to the latent trait it's supposed to measure? Where 0 would mean it's not related, it actually doesn't measure it, and more is better. And E is the error of prediction, the same as usual. So the big deal with this is that we can tell it how many Fs we have. We can do the mapping of which items measure which factors, and we can augment the model to include extra stuff we didn't think about. So for instance, if some of the items are worded positively and some of the items are worded negatively and you have to reverse score them, you may end up with extra Fs in your model that will account for the correlation of items that are written the same way. Those are known as bifactor models in IRT. They're also known as method factor models in an SEM literature more broadly, and we'll have lots of examples of those. So it is a linear model. That means that if you have responses, say, from 1 to 5, one of the things that you'd want to know is, okay, at what values of F do the predicted responses actually stay in bounds? Because if they go out of bounds, then that can't possibly be the right model. So a lot of the time, this will not be sufficient for ordinal data. Only if it's symmetric and has enough categories will it work. So for binary or ordinal data, we need a different kind of model that looks really different, but it's fundamentally the same. The one thing that changes in terms of how you make your test better from this perspective is that we pay attention to the item characteristics. How do we get a better measure? Not just more items, more better items, because they have to be related. So this loading slope thingy here, we can look at that and say, okay, I want items that have strong slopes, strong discriminations, strong relationships. And if I were trying to make a short form, for instance, I would want to get rid of the items that have the lowest slopes and keep the ones that are the strongest. So not just more items, but more better items. All right, 313. What do you say we end 2 whole minutes early, just like I did for the previous class? I know, right? It's exciting. We'll pick this up on Thursday. Any questions before we call it a day? All right, then we'll continue the overview of what we'll talk about this semester. Hope to see you all then. Bye for now.